All right, tonight what we're going to be talking about is limiting reactant. And limiting reactant is the reactant, if you look at the word, it's the reactant, so the starting substance, that actually limits how much stuff you could make. So for example, if I had 12 hot dog buns and 8 hot dogs, the 8 hot dogs would actually limit how many combined hot dog things I would actually have, okay? I would run out of my hot dogs before I'd run out of my hot dog buns. The exact same thing works with chemical reactions. So the limiting reactant is the reactant that is responsible for a chemical reaction reaching its completion. It will be the one that runs out first, so therefore it actually produces the least amount of product. For example, with that hot dog buns, if I went off the buns, I could produce 12, because I had 12 hot dog buns, whereas I had 8 hot dogs, so I could only produce 8. So the 8 hot dogs produced the least amount, so therefore it was the limiting reactant. The limiting reactant is the one that runs out first, and if you fill out the BCA chart, it will have 0 moles afterwards. So how you solve a limiting reactant problems is you're going to be given 2 amounts of reactants or masses of each. And then what you need to do is you need to guess which reactant will be the limiting reactant. So if you have 2 reactants and you're given 2 amounts of those reactants, you can guarantee that you're going to have a limiting reactant problem. And then what you need to do is you need to just guess which one it is going to be. So when you do that, after you guess which one, you're going to assume that that reactant is used up to completion. So therefore, you're going to go to an after of 0 moles. So you're going to calculate the change in after of the other reactant if that's how much of the original reactant you used. If the other reactant is negative, then that was the wrong limiting reactant. If it was positive, then that was the correct limiting reactant because you have some stuff left over. In the end, you want to have all the other reactants be positive. So that's what you're always going to be looking for. Do you end up with a positive BCA chart? If not, then you chose the wrong limiting reactant. If yes, then you guys are good to go. So let's do an example problem. So when I have 0.5 moles of aluminum, so I'm going to put 0.5 moles up here. Okay, reacts with 0.72 moles of iodine. So when I'm filling in my BCA chart, I notice that I was given 2 reactant amounts. Therefore, I'm going to need to do a limiting reactant problem. It asks me how many moles of excess reactant will remain. So here's the first step. So I'm going to assume in this first reaction that aluminum was the limiting reactant, which means that I started with 0.5 moles of aluminum. And I started actually with 0.72 moles of iodine, okay? But what I don't know, what I'm going to assume is that I'm going to lose all of that aluminum. When you assume that aluminum is the limiting reactant, it is going to lose everything so that it ends up with 0 moles left over. So what I need to do now is I need to figure out what is my molar ratio. If I lose 0.5 using that molar ratio, how much iodine would I also lose? So I'm going to need to set up a proportion. So I've got 0.5 moles of aluminum. Okay, and I'm trying to figure out what would my C or my change be for iodine in that situation if I lost 0.5 moles of aluminum. So I'm going to set up my proportions using the molar ratio. So therefore it would be 2 moles of aluminum for every 3 moles of iodine. When I cross multiply that, I get 0.75 moles. Okay, so if I used up 0.5 moles of aluminum, I would need 0.75 moles of iodine in order to do that. After subtraction, what I end up getting is that I actually have a negative amount of iodine, which means that I used more iodine than I actually had. Therefore, I can rule out that aluminum is the limiting reactant. So I'm going to need to do the next one. In this case, I'm going to assume that iodine is the limiting reactant, which I already know is the limiting reactant, but the question asks with how many moles of the excess reactant will remain. So I'm going to need to continue with my BCA charts. So now I need to do another one, but in this case, I'm going to assume iodine is the limiting. So once again, my befores, I'm still going to start with 0.5 moles of aluminum, and I'm going to start with 0.72 moles of iodine. In this case, because I'm assuming iodine is the limiting, I am going to lose all of my iodine, which means that I will end up with 0 moles of iodine left over. So now I need to figure out, if I use 0.72 moles of iodine, how many moles of aluminum would I also use? So I'm going to set up my molar ratio again to figure out my C for aluminum. So I've got 0.72 moles of iodine, and I need to figure out how many moles of aluminum that would be. So I'm going to set that proportionally equal to my molar ratio, which is 2 moles of aluminum on the bottom, because moles of aluminum is on the bottom on the left, to 3 moles of iodine, because moles of iodine is on the right. So when I solve this, I get 0.48 moles of aluminum. So I know that my change would be 0.48 moles. 0.5 minus 0.48 means that I would end up with 0.02 moles of aluminum left over. Therefore, to answer my question, iodine would be the limiting reactant because I ended up with 0 in the end, and I still had some left over of another substance. That other substance was aluminum, so aluminum was my excess, and I ended up with 0.02 moles of aluminum extra. All right, let's do another problem, but in this case what I'm given is that I have 15 grams, so once again I'm going to write that I got 15 grams of aluminum sulfide, so I'm going to put 15 grams, and 9 grams of water. Okay, so I know I have 2 reactant amounts, so I'm going to have to figure out which one actually limits the reaction. In this case, I'm going to assume that aluminum sulfide was the one to be the limiting reactant. But in order to use my BCA chart, what I first need to do is convert it into moles. So what I'm going to do right now is convert it into moles. So I've got 15 grams of aluminum sulfide, and I want to figure out how many moles of aluminum sulfide is that. So I'm going to set that proportionally equal to the molar mass, which is 150.3 grams for aluminum sulfide. And I am going to know that that would be for 1 mole of aluminum sulfide. So when I cross multiply this, I get that if I had 15 grams, I had 0.0998 moles of aluminum sulfide. So right now I'm going to fill in my B chart for 0.0998 moles. All right, next thing, I need to figure out how many grams or how many moles is in 9 grams of water. So I set up my proportions, 9 grams of water for every X moles of water, which is equal to 18 grams of water for every 1 mole of water. So therefore, when I cross multiply this, I get X equals 0.5 moles. So I'm going to put down 0.5 moles for my water. All right, so now what I need to do is figure out what my C's are. If I am assuming that aluminum sulfide is the limiting reactant, then I am assuming that it will go to completion and lose every single mole that I started with. So I'm going to end up with 0 moles of aluminum sulfide. So in order to do that for water, what I'm going to need to do is set up a proportion. So I've got 0.5 moles of I'm sorry, I don't want water. I need to figure out that if I lose 0.0998 moles of aluminum sulfide, how many moles of water would I need? So I'm going to start with 0.0998 moles of aluminum sulfide. And I need to figure out how many moles of water would that mean that I needed. So I'm going to use my molar ratio, and it's 1 mole of aluminum sulfide for every 6 moles of water. I'm going to cross multiply, and in the end I get X equals 0.5988 moles. So therefore I would need 0.5988 moles, which means I would end up with a negative 0.0988, that's a 988 moles of water. All right, which means that somehow I used up more water than I had. So now I know aluminum sulfide is not the limiting reactant. Okay, so I still am going to assume now with this one that water is the limiting reactant, but I already had figured out my amount of moles, so I'm going to start with 0.998, I'm sorry, it's 0.0998 moles of aluminum sulfide and 0.5 moles of water, which means in this case, because I'm assuming water's limiting, I'm going to lose the 0.5 moles of water, which means that I have 0 moles of water left. So the next thing I need to do is figure out how many moles of aluminum sulfide do I need if I reacted 0.5 moles of water. So I'm going to set up my proportions, and when I have 0.5 moles of water, because remember you are only ever going to be comparing your C's through these molar ratios, so we've got 0.5 moles of water over X moles of aluminum sulfide. That is proportionally equal to 6 moles of water for every 1 mole of aluminum sulfide. So when I cross multiply these, I get X equals 0.0833 moles of aluminum sulfide. So therefore my change, if I use 0.5 moles of water, I would need 0.0833 moles of aluminum sulfide, which means subtracted wise, I end up with still having 0.0165 moles of aluminum sulfide left over. All right, so therefore now I'm ready to start answering all of these questions using this chart. So which was the limiting reactant? Well, it's the one that allows the other reactant to still be positive, so that would be water. How many grams of aluminum sulfide formed? Hydrogen sulfide formed. So what I'm going to need to do is go back to my chart, and I'm going to need to figure out how many moles of hydrogen sulfide would I be able to produce. So I'm going to base it off of my change, which is 0.5 moles of water. How many moles of hydrogen sulfide would I make, or dihydrogen sulfide, or hydrosulfuric acid, if we want to go that route. So I need to figure out how many moles of H2S do I have. So I'm going to need to set up once again a proportion. So I've got 3 moles of H2S, and you are going to set that equal to with 6 moles of water. The reason why we're using this limiting reactant one to figure out how much we could actually produce is because you always have to base every theoretical yield or possible amount that you can produce based off of the limiting reactant, because it is going to limit how much product you can make. So once you've identified the limiting reactant, that is the only BCA chart you need to fill out. So let me repeat, once you identify the limiting reactant, that is the only BCA chart you need to fill out. So when I cross multiply this, I get X equals 0.25 moles. So I'm going to have started with 0, and now I'm going to produce 0.25 moles, which means 0 plus 0.25 is I'm going to end up with 0.25 moles of H2S. Okay, so now going back to the question, how many grams is that? So now I know that I formed 0.25 moles of H2S, and I need to figure out how many grams that is. So I'm going to set up my proportion, and I know that the molar mass of H2S is 34.1 grams, which is equal to 1 mole of H2S. And you are going to cross multiply, and you get 8.5 grams, or rounded to the 1 sig fig because of 9 grams of water, it is going to also be 9 grams. And how many moles of excess reactant remain? All you have to do is look at your BCA chart, and if I look at it, it's the 0.0165 moles. So I'm going to fill in 0.0165 moles of Al2S3. All right, hopefully you have a basic understanding of how limiting reactants work, and have a good evening.